This is my week 8 video log for my independent study. This week I spent most of my time focusing on improving performance improvements in the collision systems for both P2 and Gunship. If we run the collision test right now in P2, we'll see we get pretty consistently 79, 80 FPS, the scene update time around 12 milliseconds. Running in Gunship, we get similar results, 12, 13 milliseconds. Generally gives me about 80 some frames per second. So both of the engines are now performing at pretty similar levels. I'm kind of down to micro optimizations in both cases. This week, actually, I didn't do much code change. I didn't do many code changes in Gunship. I did spend time taking a look at the compiler options that I was using, because I had made some improvements to P2, and suddenly it was vastly outperforming Gunship, and I was really confused because I couldn't find any major bottlenecks in Gunship. So I started looking at the compiler settings on both of them, and P2 had compiler optimizations turned on and Gunship did not. So I started playing around with the compiler optimizations. I ratcheted up all the optimization flags about as high as I could and saw what I had on them, and that got both of them performing to similar levels. And if we take a look at the options that we've got going on in P2, you can see that we've got just about the same options set in P2. So that was interesting. It was interesting to see just how much the compiler flags were affecting performance, because I figured that turning optimizations up higher would improve performance a bit, but I didn't think it would account for the big difference in performance I was seeing between the two engines. So a lot of what I've been doing is familiarizing myself more with VTune. Previously, I was using, if we hit this, VTune's got a number of different options for performing profiles. It's got these algorithm analysis type of things. These are based on CPU sampling, so every 1,000 times a second or however often, it'll stop the CPU and check which functions in and get the call stack, and it uses that to determine which functions are taking up the most time, which lines of code are taking up the most time. But that doesn't give you very accurate analysis of what specifically is going on at the hardware level. But VTune has this other category of microarchitecture analysis, and these use hardware event sampling rather than just general purpose sampling, and this collects a bunch of metrics from the CPU, things like branch mispredictions, cache misses, pipeline stalls, and that allows me to hopefully get a better view of what down at the hardware level is causing performance problems for me. If we take a look at this general exploration view, it's giving me, this is a profile from the latest version of Gunship. In the summary view, it highlights for me which metrics, which data points it's collecting are indicating points, like areas that need improvement. For example, it's kind of slowing down on me. For example, it points out that floating point arithmetic is a potential bottleneck for me, and it's specifically pointing out that I've got a high amount of scalar floating point operations happening, but a very low amount of vectorized floating point operations. So it's suggesting that I need to make some changes to allow vector code to be generated, and that makes sense. I haven't put any time into vectorization for my floating point math, so I'm kind of relying on what Ogre is providing for me, which is not a lot in terms of the collision system. It also shows me other things like whether if I'm bound at certain cache levels like L1, L2, or L3. Currently, it's telling me that I'm L1 bound, though I'm not entirely sure what I need to do to improve that. It also tells me that I'm potentially bound by port utilization, though I'm not entirely sure what that means. And it gives me these other metrics and highlights some other areas, like for instruction cache misses. I know I can possibly do other things to improve instruction cache miss rate. They'll have to dig into that a little bit further. If we look in P2, I get similar metrics. If I go to the general exploration, it gives me the same metrics. Like, of course, floating point arithmetic is a similar problem in P2 because no effort was made to optimize that. In P2, one of the biggest problems is the bad speculations. It has P2 has a very high rate of branch mispredictions. And previously, Gunship was having a similar problem, and I somehow managed to fix that, though I'm not entirely sure how. But that's something that I can still dig into further in P2. One interesting thing that I did notice that I want to point out is if we take a look at, so this is P2's profile, and we're taking a look at the memory level bounds. It's highlighting L1 bound the same way that it is for Gunship, but here it's also highlighting storage bounds. And in both cases, it's highlighting this DTLB overhead metric. And for both cases, it suggests increasing data locality to improve this result. If we look at Gunship, it doesn't highlight that for Gunship. Store bound isn't a problem in Gunship at all, and for L1 bound, DTLB overhead doesn't seem to be a problem. So that, to me, suggests that those, my theory that the architecture of Gunship allows for better cache or better data locality, that's suggesting that it could be right in that case. However, I'm not familiar enough with these metrics yet, and I don't fully understand what they're saying, so I can't draw that conclusion yet. My hope is that by the time I do the final report, I'll understand all these data points well enough that I will be able to more conclusively say whether or not Gunship's architecture is having a positive benefit for performance or not. Looking forward for the next couple weeks, it's more of profiling, collecting data, and I'll be starting on putting together my final report pretty soon. Otherwise, I will see you next week.